Today we are going to discuss this question on complex number, H2 level question. If you would like to try and solve it yourself, pause the video right now and then you can go all the way to the end of the video to see whether you are on the right track. If not, I'm going to guide you on how to do this. So the first part of the question tells you that u is equals to x plus iy. This is a standard complex number. Show that the modulus of u square is equals to u multiplied by u star. So if u is equals to x plus iy, at this point of time you have to know that u star is equals to x minus iy. Alright, and how do I find the modulus of u? This is the square root of the x square plus the imaginary component. Basically we are looking for the length of this complex number u, and so what is u square? That will be x square plus y square. You can leave it as this first, it's fine. Alright, now this question is actually better to prove when we prove from the right hand side to the left hand side. Meaning to say u multiplied by u star is going to be x plus yi multiplied by x minus yi. And you have to know in one of the properties of complex number, if a complex number multiplied by the conjugate is just equals to x square plus y square. You can immediately skip to this, or if you still don't understand the y, that will be this way. This is equals to x square minus iy square. And I square is going to be -1, and that's how it became x square plus y square. So this is x square plus y square, and this would be the same as modulus of u square, and we have proved this for part 1. Part 2 is a little bit more complicated, where they tell you there's another complex number with 0 imaginary and real parts that satisfy this. Most students are stuck here, B, where at the starting point, the question gives you this. And how am I going to relate to this? How am I going to relate to this? Because it says that by considering part A, show that this is going to be happen. What did part A ask you to show? Part A asks you to show that the modulus of any u square is going to be u times the conjugate. In order to get the modulus square, now I square both sides. X plus w square is equals to, z plus w square is equals to z minus w square. So remember, in the first part, you have shown that the magnitude of, or rather the modulus of any complex number square is just going to be x square plus, u multiplied by the complex number multiplied by its conjugate. When I do this, the next thing I can say is, so this guy is inside here, is my u now. Z plus w multiplied by z plus w star is equals to z minus w multiplied by z minus w star. This is what you are going to do for the next step. And another property of complex number is if I have z plus w star, this is the only time where my star can go in, is equals to z star plus w star. In fact, this property, students missed out. They are not confident whether my star can go in, because when we do algebra, a plus b square, the power cannot go in. This is wrong. But in complex number, this is a property of the complex number, that you have to know. Also, I will put this in. This will become z plus w multiplied by z star plus w star equals to z minus w multiplied by z star minus w star. All I need to do now is to expand everything that is in this component. So I will have z star, so do it carefully, this way as well as this way, plus z w star plus w z star plus w star. Is equals to right hand side, I'm going to open it as well. Z star plus z w star minus w z star, plus w star. So when you do this, then you will realize that, in fact, I think this is a minus. Okay, let's do it properly. Okay, let's see this multiplied by this, and this multiplied by this. Yes, so this is a minus. Okay, I have z star here, I have z star here. So this guy and this guy will negate each other. I have w star here, I have w star here. This guy and this guy will just negate each other. So I'm just going to left with zw star plus wz star is equals to negative zw star minus wz star. Bring everything to the left side, I will have 2 times of zw star plus wz star. If you cannot see, basically it's just bringing this to the left side. I will get 2 times of zw star as I was also bringing this to the left side equals to 0, and hence zw star plus wz star, okay, is equals to 0, which is what the question asked me to show, okay, shown. So the learning point of part B is how to start. I'm given this. How to relate it to here, because first part is telling me this, or just square both sides. And after I square both sides, I apply what part A have shown, and the important learning point is if you have z plus w holding star, you can give the star to both z and both to w. Okay? For part C, it actually also tests on whether you know your properties well enough of complex number. So if let's say I have u, okay, which is x plus iy, and u star, which is, okay, x minus iy. What can I say about u plus u star? Okay, that will be equals to x plus iy plus x minus iy. You will realize you will get 2x. Okay, and x is, this part you must understand, the real part of u is x. The imaginary part of u, okay, is equals to y and not iy. The coefficient or the component that comes with the I is called the imaginary part. So if I have u plus u star, this, okay, so all these should be learning moments, learning points. It should be in red. Okay, it's going to be 2x, which is the 2 times of real component. Similarly, if I have u minus u star, okay, this is going to be 2 times of y, okay, or rather 2 times of iy, which is 2 times of the imaginary part, okay, of u. So this is also a property that you have to identify from part B to part C, because part B we have already shown that zw star plus wz star, okay, is equals to 0. You have to relate that, hey, what is this and this? This zw star, I'm just going to keep it, is the same as w star z, the conjugate of w star z. And this is the hard part about proving of complex number. Even though complex number, usually there's only 3-4 types of question. Simultaneous equation or conjugate root theorem, okay, equals to 0. So let's say I can say, okay, let u be equals to zw star. All right, so this here would be u, and this here would be u star, equals to 0. Okay, and from above, you can see over here, what is the property of u plus u star? And that is going to be the 2 times of the real part of u, okay, which is equals to 0. I'm just writing it down, this to this. If the real part is 0, that means for u is equals to x plus iy. And I have told you that this part is equals to 0. This means that the u only have the imaginary component. Okay, and that is how we conclude, therefore, u is purely imaginary. Okay, because the real part is equals to 0, and again, it touches on the whether you know the properties of, okay, complex number. For the third part, it talks about whether you know how to find the argument in the correct quadrant. Okay, now the thing about argument is it must be between negative pi to pi. And if your trigo is strong, there are 2 things that we should be talking about in this question. In A, theta is equals to alpha. Okay? in here, theta is equals to pi minus alpha. Okay, so for the first these two quadrant, okay, this is fine. But in T, we are so used to having theta is equals to pi plus alpha, and when in C, we are so used to having theta is equals to 2 pi minus alpha. These two, does it satisfy the range of minus pi to pi? Okay, the answer is no. All right, it doesn't. Because, yeah, see, pi plus any angle will be greater than pi, right or not? But my right bound is pi. So from the concept of graph, in order, I'm just going to use sine graph as a answer. Okay, so this is the usual one that we know from 0 to 2 pi. If I want another answer, so for example, I know that there's an answer here in the third quadrant and the fourth quadrant. But if I want to go backward, there, when I draw this line, it can also give me an answer here and answer here. Okay, so how to go back one period in our secondary school knowledge is we have to minus 2 pi, because a period of a trigograph is 2 pi, or rather specifically sine and cosine. So in this case, I minus 2 pi, I will get negative pi plus alpha. If I minus 2 pi over here, I'm going to get negative alpha. Okay. In secondary school, what we are commonly used to is calculating the angle this way. Okay. But for complex number, the way that the angle wants you to count is from 0 to pi is this way. Okay. And from negative pi to 0 is actually this way. Okay. So to get the argument in the third and fourth quadrant, we use negative pi plus alpha, okay, or minus alpha for T and C quadrant. Okay, so this is the first thing about trigo that you have to know. And of course, the other one would be your special angle table, 30, 45, okay, 60, sine, cosine, tangent. And in this case, tangent 30 is 1 over root 3. This is 1, and then this is root 3. Okay, I think this is root 3. So this question says W is equals to negative 1 plus I root 3. In the Argand diagram, where is X is negative 1, that will be here. Root 3, that would actually be here. Okay, and then we are getting something in the second quadrant. Okay, so I can say that theta, or rather let's always make it a habit to use basic angle is equals to sine tangent inverse, tangent inverse. Okay, y over x, and this is your basic angle. I'm just going to use tangent inverse root 3 over 1. Do not use negative 1. Okay, and the basic angle, that will be 60. That will be pi over 3. In the second quadrant, so that's why theta is just easy. I'm just going to use pi minus pi over 3, and my answer is 2 pi over 3. That's all. Find the possible exact value of theta. Okay, but as bonus, I'm going to show you one more. If let's say they tell you W is equals to negative 1 minus root 3i. And in this case, you know that negative 1 is here, negative root 3 is here, and it's going to be in this quadrant. Okay, my basic angle is still tangent inverse y over x. Okay, so I'm just going to get pi over 3, which is actually from here. Yeah, so in my third quadrant, my theta, there's two ways to do it. If you can remember, is minus pi plus alpha, then you just go and use minus pi plus alpha. But if you cannot remember it, and let's just use the secondary school method, this will be pi plus pi over 3, which is pi is 3 whole, so this is 4 pi over 3. Okay, is it out of the range? Yes. So in order to fit into the range, I must minus away 2 pi. Okay, so 4 pi over 3 minus away 2 pi, then I will get negative 2 pi over 3. Okay, that is how to find an argument in the third quadrant. Okay, where T is in the tangent quadrant. Okay, and one more. So let's say if W is equals to 1 minus root 3i, and you know that it's going to be in the here 1, and this is negative root 3. So basic angle, again, I know is inverse tangent y over x. Do not use negative values for tangent, keep it as pi over 3. Okay, now my theta Okay, I know it as negative alpha, so this is just going to be negative pi over 3. Okay, or if you are going to use the secondary school method, that will be called 2 pi minus pi over 3, which is 6 minus 1, so this is 5 pi over 3. Then my theta, because this is out of the range, I must minus away 2 pi, 5 pi over 3, minus away 2 pi, you will get negative pi over 3, okay, which is the same. So for argument, it is important to know in the third quadrant and the fourth quadrant, it is not like your secondary school anymore, because we need to fit it into the range of negative pi to pi, so we have to use minus pi plus alpha as well as negative alpha, and never ever inverse a negative value when you are looking for a basic angle. Okay, so this is how, okay, so for those of you who paused it at the start of the video, this is the answers for the first part. Okay, you can pause it right now to check whether your working is correct. Okay, as well as this is the answer for the second part. The answer is actually over here, but I'm just explaining how to find the argument in the third quadrant and fourth quadrant, and I hope it helps you to have a clearer picture of, okay, what complex number is like. Cut.